All right, this is the problem that we went over in class on Tuesday, but I'm going to use it as a sample problem again so that you can review how to do these problems. This is problem 2.22. And so I'm going to review that with you, and then we will talk about how to do a different problem or a different setup for the problem. So again, this is problem 3.22, and let's look at what they've given us in the problem. So they've told us this, we've got our chemical equation for this problem. That would be what's in my handwriting here at the top. And it is an equilibrium reaction, and then the information that they gave us in this problem is that at equilibrium, the 1 liter vessel was found to contain 0.5 moles of H2, 0.02 moles of S2, and 68.5 moles of H2S. Okay, so the reason that that 1 liter is important is because remember that we talked about we could write this as 0.5, so that would be for H2. We could write this as 0.02 for S2, and we could write it as 68.5 of H2S. And the reason it's important that they told us it's in a 1 liter container is because these brackets stand for concentration. That's shorthand for concentration, okay? And concentration is expressed in moles per liter. So the fact that they're giving us moles, but they're telling us that this is in a 1 liter vessel, we know that we can take those moles and say, well, the concentration of those moles is 0.5 moles per liter because it is a 1 liter vessel. Okay, the next thing which we want to look at is when they give us a reaction and they want us to basically find the KEQ for it, the first thing they're going to ask us is what is the KEQ expression? And what they mean by KEQ, and I want you to answer this before I write it out. What is KEQ? What over what? Okay, hopefully you said products over reactants, and what we are talking about is the concentration of the products divided by the concentration of the reactants. So that is a general KEQ expression. It is always going to be products over reactants. For our particular equation that we're talking about, our particular reaction, again, what are the products for this reaction? I'm going to pause for a moment and I want you to say that answer out loud. Ideally, why don't you pause the tape or the video and actually write out the KEQ for this particular reaction. Putting products over reactants. So pause the play and write that out. Okay, hopefully you remembered that products are on the right-hand side of our chemical equation. Okay, and the reactants are on the left-hand side. Okay, so that's important because we're always going to be putting products over reactants when we write out our expression. Okay, so in this case, our products are the H2S. But remember what's special about this particular equation. We've got this 2 as a coefficient in front of the H2S. So basically we have for every 2 moles of H2 and 1 mole of S2, we get 2 moles of H2S. Okay, so we need to put that superscript up there. So we're going to take the concentration of H2S and we're going to square it. That's our products. On the bottom of my equation, we should have our reactants, which are hydrogen gas and sulfur gas. Okay, but again, my hydrogen gas has a coefficient of 2. So once again, I need to put a superscript there. Once I have this part of my equation written out, then I can simply plug in whatever numbers they've given me. All of this information was given to you in the problem. If you read through the problem, there will be certain pieces of information that will be given to you. Okay? So we can take this information and we can plug it into our KEQ expression. So our concentration of H2S, okay, that was given to us. That's going to be 68.5. We are going to square that because according to our chemical equation, I get 2 moles of H2S every time this reaction runs. I'm going to substitute the concentration of H2, which is 0.5. That's going to go in for the H2 here at the bottom, and I'm going to square that, okay, because H2 has a 2 in front of it. I'm going to substitute in the 0.02 for the S2. I don't square that because it doesn't have a coefficient. We know that that coefficient, if there's not a written number, that coefficient is 1. Then if I just do the math, I will have solved for what my numerical value for KEQ is once this reaction reaches equilibrium. Okay, so pause the video, do the math, and then come back up and see if your answer agrees with mine. Okay, the answer that you should have gotten is going to be a fairly long calculator answer, but we're going to express things in scientific notation, and it's going to be 9.38, I'm rounding it to just 3 digits, times 10 to the 5th. Okay, so that is the first type of problem that you're going to get as you're working through these types of. All right, I'm going to take this same problem and I'm just going to present it in a different method because sometimes you will be asked to solve the problem in the way that I'm about to show you. I'm not going to do the next one, 3.24, because I want you to apply this concept to that for homework. But I'm going to basically just rearrange this problem so that it's similar to what we see with the next one. Okay, so for the next problem, all right, I'm still taking the same reaction, but they're going to give us the information in a different fashion. So we still have the 2 hydrogens plus 1 S2 goes to 2 H2S. Okay. What they're telling us, what they're giving us in this particular problem, they're giving us the KEQ value. Okay. They're asking what is the equilibrium concentration of S2 in a 1-liter vessel containing 0.5 moles of H2 and 68.5 moles of H2S. Now these concentrations, once again, are once this reaction has reached equilibrium. So again, we're going to do the same thing which we did before. The equilibrium constant is always what over what? And I'm hoping that you're at home telling the screen, products over reactants. Okay. The next thing which I'm going to do is I'm going to write out that equilibrium expression for this particular reaction. So once again, my products are on the right. My products are the H2S. I have a coefficient of 2 in my balanced equation, so I'm going to have to take that concentration and square it. Okay, my reactants are my hydrogen gas, but it has a coefficient of 2, so I need to square that value, and I'm going to multiply that by the concentration of my S2. S2 does not get squared because it has just a coefficient of 1, so it is just that concentration as we've been given. Once again, they're nice enough to have this occur in a 1-liter vessel. So they're telling us in that 1-liter vessel that I have 0.5 moles of H2, okay, so that means that my concentration is 0.5 moles per liter, so I can express it using those brackets, okay. My concentration of H2S, okay, is 68.5 moles per liter. Okay, so I can express that as 68.5. And my S2, that's what we're looking for. That is our unknown in this particular problem. Okay, sorry, I updated my tablet and it's doing weird things, so I apologize. Okay, so we're going to put X in for S2 because we want this to look like a familiar math equation. Okay, so we're going to substitute in the numbers that we have. So they want us, we have one other number. They've actually given us the KEQ. Okay, so I can take that and I can say, okay, I know that 9.38 times 10 to the 5, that's my KEQ, equals concentration of H2S squared, so equals 68.5 squared, I'm just substituting that number in, divided by 0.5 squared, I'm substituting the value of H2 in, times X, which is going to be the concentration of S2, the number of moles of S2 in that liter vessel. Okay, now this becomes just a math problem. My students, I know you get this in math, but for some reason you don't want to transfer it to chemistry. Okay. First off, because X is in the denominator, I really want to get X up to the top side of my equation, okay? So to do that, remember that I'm going to multiply both sides by X. So I'm going to put an X on the top here so that I have X divided by X, which equals 1. But whatever I do to one side of the equation, I have to do to the other side of the equation. So I'm going to multiply both sides of my equation by X. That's going to cancel these X's out, and I'm going to be left with 9.38 times 10 to the 5th equals 68.5 squared divided by 0.5 squared. Okay, I can't forget my X. Now, I want to get X all by itself on one side of the equation. To do that, I need to divide this side of the equation by 9.38 times 10 to the 5th so that I can cancel out this number. But if I divide one side of my equation by that, I have to put it on the other side of my equation. I'm just using the brackets here so that you can kind of see that it's just a separate part of this equation. Okay, 9.38 times 10 to the 5th divided by 9.38 times 10 to the 5th equals 1. Okay, so that part, I now have just X on this side of my equation, and X is going to equal whatever this number is when I put all those numbers in my calculator. I'll give you a hint. Since I took this from the last problem and I used the same numbers, X should come out to be 0.02 moles of S2 in that 1 liter vessel. So these are the two different ways that you may be presented with a problem that involves the equilibrium expression. They'll either give you the concentrations of all the reactants and products once that system has reached equilibrium, or they will give you the KEQ value for that particular equilibrium, and they'll give you some, but not all, of the concentrations of the reactants or products. They'll leave you with one unknown. You have to write out your equilibrium expression for that particular reaction. Then you're going to substitute in the numbers which they've given you so that you can solve for the number that they're asking you to find. Okay? So, watch this, pause it when you need to, make sure you're doing the work as well, and then you should be able to apply this same process to the questions 3.24. Okay? And again, I gave you questions to answer, which should help you with 3.25 and 3.26. Okay, and then I would also like for you to just read the section on equilibrium variables and try to answer 3.27 through 3.29 as part of your homework. I hope you found this helpful.